We will now determine Taylor polynomial of order 3 for the given function f of x equals natural logarithm of x at a equals 9. So here we have the Taylor polynomial expansion, that is Pn of x, where n represents the order, and this equals f of a plus f prime of a times of x minus a raised to the power of 1 divided by 1 factorial plus f double prime of a, which is basically the derivative, the second derivative of the function at a times of x minus a quantity square divided by 2 factorial plus f triple prime of a times of x minus a quantity cube divided by 3 factorial plus and so on till n. So we will utilize this expansion. So first I'm going to write the Taylor polynomial expansion centered around a. So I'm going to replace a equal to 9 into this equation and n equal to 3. So that means we can write down Taylor polynomial for order 3 as p3 of x. So this equals f of a, which is we have to find f of 9, plus the second term is f prime of a, which is f prime of 9 times of x minus 9 raised to the power of 1. So I leave it as it is, divided by 1 factorial plus f double prime of a, which is 9 times of x minus 9 quantity square divided by 2 factorial, and the last term is f triple prime of a, that is f triple prime of 9. Maybe I multiply it here, x minus of 9 raised to the power of 3 over 3 factorial. So basically we have to determine these values, that is f of 9, f prime of 9, f double prime of 9 and f triple prime of 9, and then we will substitute into this equation. So let's have the f of x. We have f of x equals natural logarithm of x. So this implies f of a, which is f of 9. We replace x by 9 into this natural logarithm of x. So therefore this becomes natural logarithm of 9. We then find the derivative of this function f of x, which is f prime of x. So here we find the derivative of natural logarithm of x, which equals 1 over x. So we can find the f prime of 9, which is the derivative of the function f of x at 9. So this equals, we have to replace 9 into this equation, that is this becomes 1 over 9. Now let's go further and find the second and the third derivatives. So here I'm finding the second derivative of the f of x. So therefore I have to find the derivative of this one. We can find it using the power rule, that is x 1 over x is equal to x raised to the power of negative 1. So when we find its derivative, we put the power in front, that is negative 1 times of x raised to the power of negative 1 minus 1, which is negative 2. So basically this is equivalent to negative 1 over x squared. So I write down negative 1 over x squared here, and this implies we can find the f double prime of 9. So we substitute 9 into this equation. So therefore this becomes negative 1 over x squared, which is 9 squared, and this becomes negative 1 over 81. Now let's find the third derivative. So therefore third derivative of the function f of x equal to, we find the derivative of this function negative 1 over x squared, and this we can rewrite as negative of x raised to the power of negative 2. So we have to find the derivative, which means we can apply the power rule. So this negative 2 comes in front, we already have a negative, so negative times of negative 2 is positive 2, and then x raised to the power of negative 2 minus 1, which is negative 3. So basically this is equivalent to 2 over x raised to the power of 3. So we can write down here, that is the third derivative of the function is 2 over x cube. So this implies we can find the f triple prime of 9. We replace x by 9 into this equation. So this becomes 2 by 9 cube, and that equals 729. So now we have found all the values which we can substitute into the equation. So let's do that. So we will now substitute the values of f of 9 f prime of 9, f double prime of 9, and f triple prime of 9 into the equation to find the Taylor polynomial. So we have fp3 of x. This equals f of 9 is a natural logarithm of 9 plus f prime of 9, which is the first derivative of function at 9, and this equals 1 by 9 times of x minus 9 divided by 1 factorial, which is 1, so I leave it as it is, plus the third term is f double prime of 9, that is negative 1 over 81. So I write down negative 1 over 81 times of x minus 9 quantity squared divided by 2 factorial, which is 2, plus the last term is f triple prime of 9. So it is 2 over 729 times of x minus 9 quantity cube divided by 3 factorial, which is 3 times of this equals 3 times of 2 times of 1, which is 6. So I put 6 here. Now let's simplify this. So therefore p3 of x, and this equals natural logarithm of 9 plus the second term, we write down this as x minus 9 by 9 plus the third term, in fact it is negative, so I change this to negative. Negative of x minus 9 quantity squared divided by 81 times of 2, and that equals 162. We then have we can cancel this 2 with 6 as 3 times, so we multiply 729 with 3 in the denominator, and that gives 2187. So therefore the last term is x minus 9 raised to the power of 3 divided by 2187. So basically this is the Taylor polynomial of order 3 at a equals 9.